Bismillahirrahmanirrahim. This is a very short video from chapter number 7, and this I had missed in my playlist, so I'm just making it. I will be dealing example 7.9 and practice problem 7.9, and primarily this is related to integrals involving impulse function. Now, what is an impulse function? This type of a function which has a value of 1 and it is only present at time t is equal to 0 is called the impulse function. It is also called Dirac delta function. It is also simply called delta function, and it is represented by this symbol. Now, if we shift the function or move the function, like here it is delta t plus 1, what does that mean? Okay, so to find, we put t plus 1 equals 0, and that means t equals minus 1. That means the function has moved to point minus 1. So like shown here, at minus 1, the function has moved, and now this will be called delta t plus 1. And similarly, if it is delta t minus 2, that means t minus 2 equals 0, t equals 2, so the function has moved at time 2, so this is delta t minus 2. Now, with this in mind, we'll be also looking at what is known as shifting property. And shifting property says that any function, when it is multiplied by a shifted delta function, this has moved, shifted by t0, then we can write its value to be the function itself, ft, and we replace t by t0. It can also be written as ft0. So we'll be using this property. Now, example 7.9 has two parts. We'll do the first part, A part first, and then the B part. And as I mentioned, we'll be using this formula. So the first part, this is the function and this is delta. So what we'll do, we'll put the function, and then for t is equal to t0 here, our t is equal to 2. So we'll write it, the function itself, and then the condition is that t is equal to 2. So we'll put now the value of t, so it will be 2 squared plus 4 into 2 minus 2. And the answer is 4 plus 8 minus 2, which is equal to 10. So this is the answer. Very simple. Now let's go to the B part. Follow same technique, but this has now two functions, cosine and sine functions. So we'll separate them. Remember, the integral, whether it is from minus infinity to infinity or from a to b or from 0 to 10, does not affect our calculation as long as the t is within this range. So we separate this into two parts, and then you can see cosine t, et cosine t is shifted by t is equal to 1. So we'll write it et cosine t, and the condition is t is equal to 1 from here. Similarly, the second part will be e minus t sine t, and now the t is equal to minus 1. Now putting t is equal to 1 and minus 1, we get this equation. And now by using our calculator, we can solve this. So let's see. This is our calculator. And if you look carefully, this is in decimal mode. Now, since our is the cosine 1 does not have degree, this is degree mode. So it is not in degree mode, rather it is in radian mode. So we have to change the mode of our calculator into radian. And for that we have to press this button, alpha, and then mode. Sorry, it's the other one. Let's say shift and mode. Okay, and this one you can see 4 is for radian, so we'll press 4, and now we are in radians. This is very small, but it is in radians, and now we can calculate this value. So let's write E. Now this is E, so we write shift E -1, we move forward, cosine 1, then we go to cosine bracket 1, and this will be equal to 01987. Let's see, 01988 or 87. Same way you can solve the other one. Shift E. Now remember this is +1, so +1, move ahead, sine -1 equal sign, that is -2.287, so this is the value, and then we can add. So this is the answer for part B. Now we go to the practice problem. This also has 2 parts. We'll follow exactly same technique. The answer is given. So the first part, delta is shifted by t is equal to -3 from here, you can see. So we'll put the condition. This is the function, and the condition is that t is equal to -3. Putting the value and solving, we get the answer to be 28, which is in the first case 28. Going to the next part, this one. Now here t is +5, t -5 is equal to 0, therefore t is equal to 5. So this is the function cos 3t, and the condition is that t is equal to pi, not 5, sorry. So we'll put t is equal to pi here. So it will be cos 3 pi. And again, you can use your calculator to find cos 3 pi. So 3 shift pi bracket close is -1. So -1 is the answer. And just for your information, many times the students forget, and then when you go into the normal mode, that is the degree mode, you get confused. So it is better that after you have solved this, you go to the shift setup and then go to the normal math mode or the line mode. We have to go to the degree mode. So we have to go to the degree mode 3 equal sign. So now you are set for further working. I hope you have been able to follow this. Please let me know through your feedback. Thank you.